Right, let's do the first homework, which was the resistivity. Very good, go on. Right. Maybe you shouldn't sit there. Okay. Let's see. Whew, all right, do you have the questions there? Right, number 1. What do I ask? Can you open it, please? You're going to get it there, are you? Great. Who has it?
I will.
You will. Yeah. We'll start with number 1.
Oh, okay.
Yeah.
Sometimes your teacher uses a nickel coin
Yes.
when his batteries are too short for his toys. A nickel coin is 50 millimeters wide. And
Okay, let me just... 50 millimeters wide. Oh, 15.
Yeah.
Okay. Of course, it's a coin. 15 millimeters
And 2 thick.
and 2 millimeters thick.
How much resistance is added to it?
Okay, so the resistance is rho L over A, which is rho L over pi r squared. So I just need to know, well, hang on, the length is 2 times 10 to the minus 3. The area is pi 15 over 2 times 10 to the minus 3 squared. And what's the resistivity constant for nickel? Do you have it in your table?
6.99 multiplied by 10 minus 8.
10 minus 8. Great. So let's hit this in the calculator and see what we get.
7.9.
What did you get, Fwang? 7 point?
7.9 multiply
Yep.
10 minus 7.
10 power minus 7.
I got 79 multiplied by 10 minus 7.
Oh, that's different.
What did you get?
79 multiplied by 10 minus 7.
What did you get?
7.9.
7.9. I got 7.9.
10 minus 7 though. Yeah? We'll find out right now. Yes, this is correct.
7.9?
Mm-hmm.
Yeah.
Yep. Or, if you want, 791 nano ohms. No. Okay. It's no big deal to change it into nano ohms. All you do is divide by nano and multiply by nano. So, it's no big deal. Right, number 2 I said was the hard one, wasn't it? Yeah. Now, what's happening in number 2, I don't know if you've ever seen this, I can do it in class. If you take a pencil and if you write on a piece of paper and then connect it up to that cell,
Oh, it's a graphite.
yeah,
So it's
it will, a current will pass through the pencil on the paper. And I'll do this in class. So I can put, have you seen this before?
No.
No, I can put a voltmeter here and you'll see that I'll get a voltage. Just the pencil on the paper, I can have a current go through the pencil on the paper. Because it's a conductor.
Yeah, graphite is a
Yeah, so it does work, and I'll show you it in class. Alright, so Ian, what information do I give you?
A student draws a very thick line on her notebook.
Yeah.
The student runs a current through the pencil. And because graphite is a good conductor, the current does not experience much resistance. If the line she drew was 10 centimeters long,
Okay.
and the resistance was 0.5 ohms, calculate how thick the pencil is drawing.
So, this pencil, I know it looks flat, but it's actually sitting on top of the paper. Now, what shape would you like to make it? You see, this is the thing. If you imagine, can you look? If I write the pencil on the paper, and then I'd look, what shape will this be? I mean, will it be like a cylinder?
Yeah.
Will it be like a square? What do you think?
It's like, like
Cylinder-ish.
Yeah, we're not 100% sure. So it's okay. We just need to choose a shape. It doesn't really matter too much if it's not perfect. Just what do you think is the best shape to use?
square.
We could go with a square perhaps. Yeah? We can just go with a square. We'll make it a simple square. But of course in real life the pencil, ink, graphite will not be on the paper like this. It'll probably be in real life something like this.
Yeah.
Yeah, but we'll just say it's a square, just so we can have some shape.
Mm-hmm.
And the answer won't be perfect, but it'll be close. It's better than no answer. So this we'll call it x and x to make it a square.
Yeah.
So you have the formula, or equals rho L over A, or equals rho L over x squared. Now what's the or here, did I say? 0.5. And what is it for carbon?
5.00 times 10 to the power minus 6.
10 to the minus 6.
Yeah.
And this is 10 centimeters long. So, now if you went, by the way, if you went for a circle, that's also fine. You will get an answer of or. So the question was, how thick is it? So if you use the circle, your answer would be 2 or. And the answer here will be different to this answer, but not much. It's still going to be the same rough answer. Okay, so let me just see. 5 times 10 to the minus 6 times 0.10. Times 0. Yeah, divided by 0.5, and then I'll bring the x squared up and square root it. Right, so here, this would be x equals 1,000, so 1 millimeter. It's 0.001. Now, if you're wondering what answer would you get if you made it a circle, you would get 0.5 equals 5 times 10 to the minus 6 times 0.10 all over pi or squared.
So the answer is D, diameter of the paper.
It'd be the diameter, yeah. I'm just seeing what that would be. And you know, if you were to do it this way, you would get 2 or equals 1.13 millimeters. So of course it's different, but you still, in your mind, you reckon that the answer is on the size of a millimeter. This is the sort of value we're looking at. 1 millimeter, 1.3. It won't be either of these, because you know in real life it's some shape like this. So the answer is going to be somewhere between these two. So, you know, if you said to me to guess an answer, I would probably add the two together. Yeah, divided by 2. So my best guess, you know, is any answer that's near 1.06 millimeters, something like this.
Why is it divided by 2?
I'm taking the average of 2, yeah. In the exam, if this is an exam question, this will be fine, this will be fine, this will be fine, this will be fine. You're looking at some answer around about this value. Okay. Right, okay. Let's have a look at the next one. Oh, by the way, why don't I say it's a rectangle? Why don't I consider it being some shape like this on the paper? Well, the reason is because this has 2 variables. And I don't have enough to do it for 2, only for 1. Okay.
bolt of lightning strikes a tree that is 30 centimeters wide and 3 meters tall. How much resistance is the tree?
Okay, that's okay. 3 meters tall, 30 centimeters wide, resistance rho L over A. And what's it for wood?
1 over 10 to the power 14.
14,
Yeah.
like this.
Yeah.
Multiplied by 3 over pi or squared. What did we get? Did you get this wrong?
3.4 into 10 to the power 14.
4.29.
Oh, Mayor, you're not having a good day with these ones. 4 point.
29.
Yeah.
I think I'm doing the area wrong.
And,
Because
15.
Power 15. Okay. That's okay. Lastly, question 4.
A telephone company is laying down copper wiring. The
Mhm.
copper wire is 4 millimeters in diameter and 2 kilometers long. When the current is running through it, then how much resistance A will the copper wire offer?
And B if it's braided. Yeah.
Yeah.
Right, so the OR is rho L over A. What is it for copper?
1.72 10 minus
show me the
8.
Minus 8, yeah?
down.
Pi or squared. Um, 2.737? Yeah?
73, yeah.
Yeah, about this.
Yeah.
And then if we have 2 copper wires, and they're, you know what braiding looks like. The heck is this?
Doesn't look like
Right, okay, you get the idea. If there's 2 of them, the only difference is there's a 2 here, because you have this type of shape. Yeah, so that just puts a 2 here, but you realise, oh, so that just means there's a 2 there. So in fact, the telephone company would have only half the resistance, 1.369 ohms. So this is for part B, and this one here is for part A. But we'll discover something interesting in the next homework now about this. Oh, you kind of need this a little bit higher, huh? That's better. Right, next homework, yeah, we can do that one. Okay, let's have a look.
Yeah,
Let me just close this.